Multiplication of matrices. Now this is when things start to get a little bit more complicated. Okay, so how do we multiply two matrices together? Okay, so let us learn via an example. I think that will be the best way to learn this. Alright, now the first thing that we do before we can even multiply two matrices together, right, we must first determine if the two matrices are multipliable. Okay, what do I mean? Well, first thing we do, we check the order. Okay, we check out the order of the matrices that we are supposed to multiply. So this matrix here is of the order 2 by 2, isn't it? So it's a 2 rows, 2 column matrix. Okay, likewise for this will be a 2 by 3 matrix. Okay, now we have to analyze the order of the two matrices in order to decide if they are multipliable at the first place. Okay, how do we do that? Well, we pay attention to the digits here. Okay, the first thing we look out for will be this last digit of the first this matrix and the first digit of the order of this matrix. Okay, which means that we take a look at the number of columns for this, alright, and the number of rows for this matrix. Okay, now these two numbers, or rather these two digits here, okay, have to be the same. Okay, if this is a 2 and then this is a 2, then you say, aha, they are multipliable. Okay, so when cases whereby this is not a 2, this is a 2 and this is not a 2, alright, then the two matrices will not be multipliable. For example, take a look at this multiplication here. Okay, now for this, no, they are exactly the same matrix, isn't it? If you you know, alert enough. Okay, so the first matrix here, okay, this is a 2 by 3 matrix, as we have seen earlier on, and this is of course a 2 by 2 matrix, isn't it? So when we first analyze, okay, now we look at the number of columns for this matrix and the number of rows for this matrix. Now this is a 3 and this is a 2, okay, and therefore they are not the same numbers, and therefore this matrix is not doable. Okay, or rather this multiplication is not doable. Okay, and of course this multiplication is doable. Okay, of course the next thing that must be burning in your head right now is, okay, so since this matrix is doable, this multiplication is doable, how do we do it then? Okay, well, there is some more use for the order of our matrices. Okay, the orders of the matrices that we're talking about here. Now is the final two numbers that we haven't talked about. Okay, now this number here, which represent the number of rows, okay, for the first matrix, and of course this number here, which represent the number of columns for the second matrix. Okay, these two numbers will end up, okay, giving us the order of our result. Okay, which means that when we properly multiply these two matrices together, okay, we will get a result of order 2 by 3. Okay, the next thing that of course we want to then talk about is, of course, how do we do the multiplication, isn't it? Okay, since this is doable, we shall just use this as an example. Alright, now since we are dealing with so many different numbers here, okay, now you have to be extra careful, and therefore you have to learn this very, very well. Okay, you must know what you're doing and so on and so forth. Okay, now how do we even get started? Now is this. Okay, now we take the first row of the first matrix, okay, to multiply by the first column of the second matrix. Okay, how do we do the multiplication then? Well, simple. Okay, we'll take the 1 multiplied by the 2 plus the 0 multiplied by the 0. Okay, so we'll have 1 times 2 plus, of course, 0 times 0, of course, will give us a 0, isn't it? Okay, now next thing that you must know is, after you have done this column, okay, we move on to the next column, 1, 6. Okay, and we repeat the same process. So we take 1 multiplied by 1, and then of course 0 multiplied by 0 multiplied by 6, of course, will give us 0. So 1 multiplied by 1 will give us 1. So 1 times 1, and of course 0, and that's it. Okay, after we finish up this column, okay, move on to the next column, okay, which obviously will repeat the same process. So 1 times 0 and plus 0 times 3, so that will give us a big fat 0 here as well. Okay, now the moment we have finished up the columns in the second matrix, okay, first column, second column, third column, we finish it, no more column to go. Alright, we go back to the first matrix, and now we go to the second row. Okay, so we repeat the same process again, second row, but now first column, next column, and so on and so forth. Alright, so for the second row and then first column, we will do 5 multiplied by 2, okay, which will give us a 10, plus, okay, 4 multiplied by the 0. So of course that will give us a 0 as well, right? So then we move on to the next column. Okay, so after we use up the first column, we go to the next column. So we have 5 times 1, which will give us a 5. Alright, plus a 4 times a 6, which will give us a 24 here. Okay, so of course after we finish up this column, well, we go on to the last column. So they'll give us 5 multiplied by 0, plus 4 multiplied by 3, right? So they'll give us 12, of course. Okay, so our final answer, okay, of course we have to work out the addition in between here. Alright, so what I've used here is all these numbers here are rather easy to calculate mentally. Okay, so of course when you start to deal with questions that are more difficult, when dealing with bigger numbers, of course you may have to rely on calculator for the calculation of these values. Okay, so anyway, for this example, okay, we'll have this matrix here as our final answer. As you can see, our final answer will have an order of 2 by 3. Okay, as not indicated. Okay, not predicted, but as indicated by the order, okay, of these two matrices at the first place. Alright.